Hi everyone, welcome to my channel. Today in this video, we'll learn about microservices core component. So in the future video of microservices, we'll build the end-to-end architecture. In the layman term, microservices are small, autonomous, loosely coupled services that works together to form a big system. Let's say we want to develop Amazon.com with the help of microservices architecture. Now, beauty of microservices is that we could choose multiple languages for one system. Let's say we want to go for order processing in Java using a Spring Boot framework. We want to develop recommendation service in Python only, and for user authentication, we want to develop that in Node.js using the Express.js framework. Similarly, other language we could pick. The very first step is we have to choose a language and the framework that supports the microservices. After then, the second step is now no system can work without databases. So it may vary from one service to another service that which databases they have to interact. For example, in case of Amazon.com, we know we have to deal with transactions. So maybe a payment service might deal with RDMS kind of service. For recommendation or a feedback service, which might need NoSQL databases like Cassandra, catalog service might have to deal with document databases. So similar kind of like based on the use cases, we have to choose the database that for which we have to interact with the system. So next part is communication. So we have multiple services. We have payment service, we have card service, recommendation, multiple services that we have to develop. Now we need to establish a communication among them also. Why? Now when we are going to the website, so we are doing a couple of actions, right? So a lot of services are happening at the back end. We are searching something, we are putting something in cart, we are doing the payment. So multiple touch points are there. But from communication point of view, there are two important aspects. The first is synchronous communication and asynchronous communication. So we need to be very clear that do we need synchronous communication or asynchronous communication? So synchronous communication is required when we are expecting an immediate response. So we are sending something and we are waiting for that response. When the response will come, and then we'll be able to process. A real-time example, if I have to give, let's say we are talking on a phone. So we are talking with that person on real time or near real time. Similarly, we are chatting. From Amazon point of view, what are the synchronous operation that we could think of? So suppose you want to buy a iPhone. So first you are going and searching. So once you are typing iPhone, so the moment that you are pressing, immediately you are getting a result. You are putting something in cart, sync operation. And then once you are going for the payment, again a sync operation. Because until the payment is not there, so you're not able to do anything. You're waiting. So once your payment is confirmed, then something is happening at the back end. So these are sync operation which is happening with respect to microservices. And from sync operation point of view, sync communication point of view, so we have multiple protocols like we have REST, we have GraphQL, we have SOAP and other. So based on the different use cases, we may choose that where we have to use a REST, where we have to use SOAP, and where GraphQL is very efficient. Now, from async communication point of view, the similar example that we started with the real world. Now, let's say you're sending an email, and so that is an async one. You're not expecting that somebody would reply immediately. He may or he may not. From Amazon point of view, async operation could be, suppose you have now bought a iPhone. Now you want to leave a comment about that. It's not like whenever you will post immediately it will be done. So it will be happening at the back end. So the moderator would be there. They'll be reviewing the comment, and then other user will be able to see the comment. Similarly, when you place the order, so at the back end, it had checked with the logistics service or it had sent you the email confirmation. It's not like the service was blocking and once the logistics service was able to confirm and then you were able to get that one. So that's happening at the back end. So async communication is happening. For async communication, we need message brokers like Kafka de facto standard. Similarly, we could have RabbitMQ or other cloud-based services which offers this message broker kind of communication. So we should be very clear where do we need sync communication or where we need async communication. Now we are dealing with multiple services, and each service could be deployed at different locations. They would have different IP or host name. Now let's say service A wants to interact with service B. It's not possible. They would hard code the host name IP in their configuration, and in this way they'll be able to interact. Because it is very much possible the instance goes down and you need a different instance and the host name and IP would get changed. So that means there should be an entity at the backend which will take care of all the host name, all the IP addresses of different services that you host. It should have all the information that which service is hosting at which particular host name and which machine. So that service is called service discovery and register. How it works, the services comes up, they register themselves with that particular central entity, and then one has to establish a communication with other service. First it goes to service discovery, it finds the information, then it caches the information, and then it makes a direct connection with service A. Now let's say order processing service wants to interact with payment service. So order processing service will first go to service discovery, it will get the information about that particular instance, it will make a connection and also cache that information so that it doesn't have to go back again and again. Whenever this new service will come up, they will register themselves with the service discovery. This is how the service registration and discovery happening in microservices world. Now we have something at the back end. Now how clients will interact with the system, they will not directly come and interact with different services. For example, I work for Adobe and you want to meet me at my office. So it's not like the straight way you'll come to my seat. There would be reception which will make sure that whether your entry is already there in the system in terms of registration. They will check the registration and then they'll call me and then they'll pass on the information. I sit in this location. This way you'll be able to reach out to me. Similarly, from microservices world, that component is API gateway, which is like a main gate from where all the user authentication, authorization would be happening. And that API gateway will make sure that if a request is coming for payment service, it should go there. If a request is coming for recommendation service, it should go that particular instance. So that particular main component in terms of managing all the API is API gateway. We are dealing with massive amount of data. So that means we also need other components like load balancer. Now load balancer could be placed in multiple locations within the microservice architecture. First load balancer could be placed between the, let's say we are trying to reach Amazon.com through mobile or through web. So that means without first even reaching to API gateway, a load balancer would be there so that all the requests shouldn't go land to one API gateway. There would be multiple API gateways. So first load balancer will make sure that the equal distribution should go to the multiple API gateways. Once that is there, now each of the service could have multiple instances, right? Millions of transactions are happening. So that means for a payment service itself, there would be thousands of instances which are running. So load balancer will make sure the request which is coming throughout the world, it should uniformly distributed all across multiple instances. And load balancer could be public facing, private facing, layer 7, layer 4, multiple level of load balancer could be there. Now think about this one. We have multiple services, right? How we are going to deploy them? So we want something like container, because we don't want in a situation where, so whenever for a service, packages would be there, library would be there, application code would be there, and other dependencies should be there. For that one, we want to build everything in the form of container so that we could put or create in any environment where we want. So if you want to learn more about container and Docker, you can watch one of my video. We have multiple now services, multiple containers, and we also want to build the automation in terms of their orchestration, like automatical scalability should be there and automatic management should be there. So we also need something like Kubernetes. And if you don't know about Kubernetes, you can also watch one of my video on Kubernetes. So when we are developing our application, we have to take care of the logging. Once the system is in place, then we have to take care of the monitoring also. There are other aspects related to like security. We need to be very considerate about the security from user authentication point of view, from authorization point of view, from service to service point of view, from data in rest, from data in motion. So these are the considerations that we have to take. So there are other components as well, but these are the core components which are required to build any microservice architecture. What are the benefits that Amazon.com has got by adopting the microservice architecture? First, there is no single point of failure. When we say single point of failure, since it's a multiple services are running, if there is any problem with one service, it's not impacting the complete system. For example, if there is a problem in catalog service, it's not impacting the complete website. If there would have been one single application, it could have impacted the whole website. Now there is freedom to choose technology, best technologies. It's not very restricted that within a complete project they have to choose Java or Python. So one service could be developed in Python, other could be Node.js, and vice versa, and other technologies as well. Now they have a complete freedom in terms of managing their release cycle. If they have to upgrade existing service, it's not impacting. If they have to add new functionality, they're able to do so. So there are multiple benefits that comes with this microservice architecture. So in this video, we covered the core component of microservice which are required to build the end-to-end architecture. So in the next video of microservice, we'll build end-to-end architecture. Thank you so much for listening to me. I'm signing off. Thank you.